Hello everyone, this is Dr. Sachinandan Datta, and in this video lecture I'll talk about the FiSAT tool software. So first we have to create a FiSAT file. So go to file, then new, create a new file, and that is a file type file extension .lfq length frequency. So we'll create a example file, example .lfq, and then save it. So here a new file is already created. Here you have to put a species name, which species you want to work. Your species can be tuna, your species can be sardine, anything. So here we are putting the sardine. So Sardinella longiceps. And then you have to take the measurement unit. So your length measurement is centimeter, millimeter, or inch, whatever. Here my data is on millimeter, so I'm putting the millimeter. And your measurement type, whether it is total length or the fork length or the standard length, what it is. So here my data is the total length. Total length means from the tip of the mouth snout to the tip of the tail. So this is the total length. Then you have to select the smallest mid length, and you have to select the class interval. So I have already prepared a video lecture on the FiSAT dataset. So you can check this FiSAT dataset, and you can check what is the smallest length. So here is the smallest length is 121 millimeter, and the maximum is 220, and the class interval is the 10. So I'll put here smallest interval is 121 and class interval is the 10. Then you have to add the sample. So here it's created, then you have to create the add sample, and here the main thing is that you have to create your sample month wise, as we have talked about it, that FiSAT length frequency data is required for the FiSAT software, that is the length frequency data, and month wise. So January, February to December, so throughout the year. And here we select this data set, we'll work on it. And here we don't have this July and the November data set. So we'll don't select these 2 months. And so first we have to select the date. So any date, your sampling date, it could be any date. What is your sampling date? Okay, and the month January, and the year, our year is the 2017. And here is different other parameter. You can give the value of this parameter or not. So sexes you can put if your hold the set data set, male, female, or both, or unknown. So here we don't know the sex, it's putting unknown, and it's not required easily, but you can put the longitude, latitude of your sample collection, depth of this water bottom type, and then you can put your length frequency analysis, the A and B value. Then you can put your catch value, catch data, PUE4 data. So these are the things you can put, or it can be, or it cannot be. You can also put, and you no need to put. Okay, so you main thing is month wise we have to create the length frequency data. So we are adding the January month, then we have to add the each and every month, the February. Then we have to take this each and every one, that is the March, any date, your sampling date, but it's better to take the sampling date almost similar. Months don't varies a lot. So March. So regular sampling in a constant or little varies in date, it's not a problem, but it's better to make a fixed date. Then May 5th, then June, and we don't have the July data, so we are not putting July. Without July we are go directly to August. Then go to September, then October, then November we don't have the data, so we go to directly December. Okay, so here my whole month wise whole set is ready, and now you have to put the value. So I have already prepared the set for our data. So here the data is already prepared, so just select copy this data, and you have to paste on the here. So here my data set is ready. Now you just go and click the save. So my data is saved. Okay, and now one by one we will calculate it. We estimated the different population dynamic or population parameter on the life history tool. So here we have to first calculate the asymptotic length and the growth coefficient or the growth factor. So for that we have to get the direct LF data, and that is the LPIN1 program. So in this LPIN1 program we have to take it the K-scan value. So in K-scan you have go to directly calculate. If you click on calculate, so the software automatically calculate your L infinitive, that is the asymptotic length, and K, that is the growth constant. So this is the two main parameter is always required to estimate the different parameter in this FiSAT software. So these two, L infinitive and C, are the main input for other estimation of other parameter. So here we got, so growth constant in year, so year is increasing, so growth constant value in per year, and here the score. So it's a growth constant 0.51, and it could be up to 10, but it's very good to be 1, close to 1, and it could be beyond 1. So growth constant value here, our value is the 0.5, so it could be 0.58. So we got our L infinitive and K value. Now you can plot the von Butterfly growth curve here by clicking the plot BFG curve, and you can plot the BFG curve and use the reconstruction frequency, and you can, by clicking the graph output, you can got the VBGF length frequency graph, and you plot the VBFG growth curve, and you can see that here the data is in case of January, in the January month, the maximum frequency on that size group, that is the 160 to 170, that is the highest length frequency that group. So if you check in January, the highest frequency is almost 160, 170, 170. So that is the 170, 160, and the lowest is that right size that gives you the highest lowest. So lowest value is giving 150 this size group. So if you check, the lowest value is giving by this 151. So this is the von Butterfly growth curve. And if you check in another any like October, if you check, or you can check February, March, any April, just check the April. In April, the highest length is also the same, is 170, more than 170. So if you check in April, this is 170 is a 16, so that is the highest. And if you check, the lowest one is 191 and 121. So lowest one is 200, 210 and 191 also. So this is yes, so here is the 210 and 191, that is the highest lowest value. So that is the von Butterfly growth curve you can estimate. And now go to the different parameter. So we are going to estimate the mortality parameter, and this other basically require the age data. As we are not considering age data in this model, we are basically consider the length data only. So we are not going for these three parameters. Directly we go to the mortality estimation. So we are going to estimate the natural mortality first. So natural mortality, I have talked about it. So we are estimating the natural mortality from Pauli's empirical equation. So clicking the Pauli's m equation. So this is the equation, log m is equal to this some constant, and it also requires the L infinitive and K. Along with L infinitive K, we also require the T, that is the mean habitat temperature. So you have to put the L infinitive here, it is 221.55, and your growth constant K is 0.58, and your mean habitat temperature. So that is a very important parameter to estimate the natural mortality, because the natural mortality depends upon the environment. So environmental temperature or mean habitat temperature where the species lived, so that is important. In here, in case we are putting the habitat temperature, means the sea temperature where the species is found. So here we are putting almost 28.7. so you have to take the value of your facing zone, the water temperature. So that is the mean habitat temperature. And then if you click on compute, and your natural mortality is already calculated, that is 0.72. So 0.72. And now you go to estimate the other mortality, that is the Z total mortality from the length convert catch curve. And from this length converted catch curve, we also estimated different parameter, other mortalities like the total mortality, fishing mortalities, and we can also calculate the exploitation rate. So here the data is required here, the 221, that is L infinitive 0.55, and K growth constant is 0.580, and you can compute the data point, and you can check in catch curve. In catch curve you can check, and by clicking, that is the extraplot probability, by clicking the extrapolation. So you can check the other mortality rate. Here your mean habitat temperature required for this calculate the natural mortality, that we have already put 28.7, and then you go proceed. So you can get your total mortality, that is 1.62, natural mortality at 28.7 degrees centigrade, that is 0.72, and physical mortality is 0.9, and your exploitation rate, AE means exploitation rate, is 0.55. So here is the main two thing, that if your fishing mortality is greater than your natural mortality, so your fishing mortality, if fishing mortality is greater than your natural mortality, that means that your fish resource is overexploited. And that also indicate, you can also predict this thing according from this exploitation value. If the exploitation value or E value is greater than 0.5, then it is called the overexploited. Here the E value is 0.55, so it is, you can call this population is under overexploited. So here you can check the relative age, so 0 year, 1, 2, 3, 4, 5 years, and here the population. So most of the population will die in the age of 5. So I have told to you in my previous lecture that the small pelagic don't die due to the old age, because the small pelagic are die due to the fishing. So fishing mortality is very high there. So here you can check the due to the fishing, the fish is die at the whole population will almost died in the age of 5, so relative age. So that is length convert catch curve. We estimated the total mortality, natural mortality, fishing mortality, and exploitation rate. Now you can go to assess, and you can estimate the recruitment pattern. So for the recruitment pattern, we also need the growth parameter. We required the L infinitive, so 221.55, and we required K value, that is 0.580. and then you can compute. So here you can got your recruitment value the whole year. So here January, February, March, April, May, June to December, and you can see that here the species have a 2 peak recruitment, means 2 times they are giving spawning or main recruitment period. The main peak is on the January, February, March, April, May, June. June is the main recruitment peak, means this is the main spawning or recruitment time of the sardine, and one is also one peak you can find in the month of January, February, March. So March and June is the 2 recruitment peak of this particular species. Then you can also estimate it, the probability of capture. Probability of capture is important, that which net you are using to catch this species. So sardine is basically a pelagic fish, so you're basically using the gill net for capturing sardine. So you have to take the gill net selection. So in the gill net selection you have to put the mesh size, so which is the smallest group you will find from your sample. So your sample is smallest size you will found in 1, 2, 3, 4, 5, 6, 7, and the largest group we are found in the 4th. So you go, so you have to go there, and yes, gill net selection. So it's I think 7. And small mesh size, what is the mesh size? So it's could be 60 millimeter smallest mesh size, or it could be 50, 60, whatever it is, 50 millimeter or 60 millimeter. And your the bigger mesh size on that could be probably 90 millimeter. And so this is the mesh size, and after putting the mesh size, if you compute, there is compute conference. Okay, so yes, so if you click on the gill net selection part, then you can check this is normal plot, and you can check also log plot. So here you got your length values, and here is a probability of capture. So from here you can also check that which which length group is the highest probability to get the capture is the highest. So here basically 160 and then 170. So 170 length group is the highest probability of capture. So if you check your data set, then you can also found that same value. If you check your data set, so here you can check the highest probability is 89. That is also the 170 to 180. So this length group is the highest probability of capture. So now you can also go to the virtual population analysis. So VPA is basically we don't have the age data, so we basically consider length data. So length structure VPA. So virtual population analysis, we input is required, or here our input is the aim is the natural mortality, and here A and B values required, but as we are not putting A or B value, so the system is default taking the A value is 0.0001 and B value it's in the isometric growth, it's 3. So here your input value is the aim is the natural mortality, so that is 0.72, and your physical mortality required, your physical mortality I think so it's could be your physical mortality is 0.9 I think so, and physical mortality is 0.9, and your L infinitive is 221.55, and your K value is 0.58. and then if you put into compute, then you can get your physical population, virtual population analysis. So this is a length class or length group, and this is the population and the physical mortality, and you display your lesson, then you can check the which one is this. So green one is the survival. So here the small size piece or 121 millimeter size group of the piece have the highest probability or highest proportion of the natural natural survival rate, because they are not caught by the fish net, because they are very small size. So their highest probability of survival is the this group, and lowest probability of survival is the larger fish. But in case if you check the natural mortality is very high in the small group, in the very small fish, because they are much more protected, much more means susceptible to the large fish or large predator fish. Their the natural mortality due to predation or the disease or any kind of days or disease or death is the highest in this small size group. And if you check the catch, so maximum size group basically 160, 140, 150, this size group have the highest catch. And if you check the fishing mortality, maximum fishing mortality goes to 170 size group, and that is also the probability of capture is also the highest in this 170 size group. So this is the virtual population analysis. Then you can check the Beaverton hold Y by R analysis, and there is a two type of process, nipage and selection ogib. So you go to nipage, and here you can got your Y by R plot and B by R plot. So Y by R means yield per recruitment, and B by R means biomass per recruitment. So here it shows the exploitation rate in x-axis, and y-axis gives you LC by LO, means LC means first capture, length at first capture, by L infinitive, asymptotic length, and your exploitation rate. So I have told you, if your exploitation rate is greater than 0.5, that is means overexploited. And here you can check the your yield per recruitment value is going high. If your yield per recruitment value is going high, in case of high exploitation rate, if you are exploiting a lot, then your yield will be increased, and Y by R value is increased, and also high LC by L infinitive value. So you are getting very high Y by R value here, that is high exploitation. And if you go very low value of Y by R value in lowest exploitation, and low LC by L infinity value, and high exploitation but low LC by L infinity, which also gives you very low Y by R probability, Y by R value. If you check B by R, biomass per recruitment, biomass, if your exploitation is increasing, your biomass is going decline. So your biomass going decline. So here highest means B by R value, biomass by R is the highest, very good value. That's at low exploitation, means you are exploit very low, you are not exploiting, and their biomass is very huge and good, and also high LC by L infinitive. So here basically highest you got the B by R value, and if you increase your exploitation, your B by R value is also decreased, meaning your biomass per recruitment is decreased, biomass is going to decline. So Y by R, B by R basically proportion, means it's if Y by R is increasing, the B by R decreasing. Okay, now we have different other parameter like Thomson built stock. For this you have to create a different file type, but I'll talk about it in different lecture. And here are the free few supporting tool, that is you can stimulate your LF length frequency data. You can also estimate your weight from the length, and you can also one pattern track growth curve, I have already told to you, and growth performance index you can calculate here, and minimum, maximum, or maximum length estimated. So these are the not that much important to estimate. Main thing is mortality, that total mortality, natural mortality, and physical mortality, and exploitation rate, recruitment pattern, virtual population analysis, probability of capture, and Beaverton Y by R or B by R plot. So this is all about the FiSAT software, and hope you understand this software. And if you have any question, please put into the comment section. And thank you.